Welcome to the next installment of my video lecture series in economics. And in this particular video lecture, we're going to be taking a look at how to measure the benefits and costs of consumers particularly when there's trading between two people. And the thing that we're going to assume that there's something called an endowment. There's an initial allocation of goods, and we're going to keep this limited to two individuals. So the total endowment for these two people is 40 cords of wood and 80 candy bars. And the two individuals, one is Jane. She has 30 cords of wood and 20 candy bars. And Denise has 20 cords of wood and 60 candy bars. So here we're going to have our typical indifference curves. However, you notice that we've got these denoted with J and D. So we know that this is the indifference curve 1 for Jane, and this is the indifference curve 1 for Denise. So we're going to be on that indifference curve. So that's the initial endowment for Jane. Jane has 30 cords of wood, and Jane has 20 candy bars, and that leaves 20 cords of wood available for Denise and 60 candy bars available for Denise. So all we've done, we've taken that initial allocation of goods, and it's been divided between these two individuals. The thing that I want you to understand with this Edgeworth box is we're going to be representing both of these individuals at the same time, and this is going to cause us to have that one person having an origin at the typical origin, and the typical origin I'm talking about the lower right. But what we're going to do is rotate another individual's, and this particular one, Denise's, 180 degrees, so her origin is in the top right. So let me show you what I mean by that. This is the original representation of Denise's endowments, with the normal origin being here on the lower left-hand side. We're going to rotate this 180 degrees so that now the origin is going to be in the upper right-hand side, like that. This is typically the part where students have the most difficulty in dealing with the Edgeworth box. That we have one individual whose utility is being represented by an origin in the upper right-hand side, and that means that as they move further downward and to the left, this represents higher levels of utility. So let me put these two together and show you what I mean by that. This is the Edgeworth box. So these are the axes here for Jane. Here's her origin, and here's the representation of cords of wood and candy bars. So there's her 20 candy bars, and there's her 30 cords of wood. And since there is only 50 cords of wood, that means there are 20 available for Denise, and there are 60 candy bars available to Denise. All right, so make sure you're comfortable with that. That's the part where students have the most difficulty with, is the fact that we've rotated the graph for Denise 180 degrees, and now her origin is in the upper right-hand side. So what we're just representing both of these individuals at the same time with their indifference curves, and that this Edgeworth box is just giving us a total allocation. So here's our initial point here. Here's the initial endowment between these two individuals. Now, let me just show you, if you take a look at this, this is the indifference curve for Jane. Everything out in here represents the indifference map that represents higher levels of utility for Jane. So let me highlight that in that light purple. So in this entire area here, if Jane were to move to an allocation in this purple area, she would have an increase in utility. Here is Denise's initial indifference curve. Because her origin is here, anything to the left of this and below would represent an allocation that would increase her utility. So the purple part is allocations that would increase Jane's utility. The light blue area is the allocations that would represent increases in utility for Denise. And as you can see, we have an overlap of where these are allocations in here, where it's both purple and light blue, that this region between the two indifference curves represents allocations that would improve or increase both individuals' utility. So for example, this point F here would represent an allocation of cords of wood and candy that would be beneficial to both Jane and to Denise. So these individuals would willingly exchange wood for candy bars in order to get to this point, because both individuals would have higher utility after the trade and the adjustment of those initial endowments. So just make sure you realize that we're talking about mutually beneficial trades. So each person is going to try to maximize their own utility. We have the same shaped indifference curves that we talked about previously. The only difference is that we have an individual whose indifference curve and their origin are on the upper right hand side, and then moving downwards and to the left is increasing, or allocations that are increasing, or indifference curves that have higher levels of utility. Again, no non-satiation. Each person has strictly positive margin of utility. That is, the more they consume, the better off. And there's no interdependence. That means that the utility of Jane does not depend on the consumption of Denise, and that the utility of Denise does not depend on the consumption of Jane. So again, let me bring that box, the Edgeworth box, out for you. And here we can again see the area where we have the allocations between Denise and Jane would increase utility. So as you can see, we move to an indifference curve that's further out for Jane. And we've done the same thing here. We move from this indifference curve to this indifference curve for Denise. So that means that they are trading their initial endowments. So what Denise is going to do, Denise is going to trade 20 candy bars and get 10 quarts of wood for that. And then what Jane is going to do is she's going to trade 20 candy bars. She's going to receive 20 candy bars and give up 10 cords of wood in order to do that. So there's her decrease in cords of wood, and there's the additional 20 candy bars that she gets. So in doing that, in trading 10, and Jane trading 10 cords of wood to Denise for 20 candy bars, both individuals have increased their utility. Their indifference curves are further away from their respective origins, so both individuals in trading have increased their utility by doing so. Make sure you realize that there are going to be multiples of this equilibrium here where the indifference curves are tangent to one another. I drew in a couple of additional purple lines here, and we have additional light blue lines here to represent allocations that the indifference curves of these two individuals are tangent to one another. And because, as I said, there's an indifference map, meaning there's infinite indifference curves there, what this contract curve does is just maps out all the allocations of wood and candy bars between Jane and Denise that maximize utility, i.e. that the indifference curves are tangent to one another. So the indifference curves of the two parties are tangent. That gives us an allocation that maximizes utility. That means that the marginal rates of substitution are equal to one another. Also, that means that there are no mutually beneficial trades are possible, that once we get to one of these points, it's impossible for any trades to occur that make both parties better off. What will happen is one party will be made better off and one party will be made worse off. That means that allocation itself is Pareto efficient. Pareto efficient means that there are no transactions left that can make both parties better off, that any transaction that occurs if you reach Pareto efficiency by default means that somebody is going to be made worse off.